Hello, everybody. My name is Cameron Pfiffer. It's a terrible last name. I wish I should have changed it, but the F's were on sale when I was born. And I work at a company called dottxt, like file extension. And our entire mission statement is basically to make AI speak computer, right? So the way that we do this is what's called structured generation. And structured generation is how you force a model to output text adhering to a specific format. I'm sure you've asked the language model to say, like, please classify this into one of three things, and the model's like, certainly, it seems like it's A. And I say, Claude, shut up. I said, say A or B or C. I didn't ask you to say certainly. Please, just give me one of those things so I can program with it, I can inject it into my database, all that kind of stuff. So structured generation is the phrase for that. So if you want to work with structured generation, you can go check out the outlines package, or you can just use VLLM, because VLLM has outlines built into it. And if you just use I'll show you an example of this, but just use VLLM. That's kind of the main point. So what I'm going to show you today in the talk is I want people to build robust AI systems, and I want people to start building them in a more interesting way than the way they're currently doing it. The way that a lot of people build AI into their systems, kind of language model stuff, is they use these like weird agent frameworks, and I love all the agent frameworks. They're very interesting, but it makes the agent framework the star of your program. The star of your program is your program. The language model should be extremely boring. It shouldn't break. It shouldn't do any of this stuff, and that's why we use structured generation. You don't need somebody else taking over your program. So I'm going to give you an example. And I'm going to build a self-expanding knowledge graph. And this is kind of a toy example. It's kind of like it's not intended to be particularly useful, but it is intended to inspire you to think about how these things should be built. Okay. So I'm going to show you this prompt that I'm going to give the robot here. You're a super intelligent AI building a self-expanding knowledge graph. Your goal is to achieve the core directive, understand humans. Give me some questions, concepts, and a list of answers, and respond in this format. So we're going to do that. But what does that mean? What is that going to do? I'll show you in a bit. So I'm going to walk through the stack, because we've gotten some lovely folks here who are all involved in the stack. And so I figured, OK, well, I'm doing this event. I might as well use everybody here, all their fun little tech, and make something with it. So Modal here makes really good compute resources. So one of the big pitches for Modal is it's really, really, really easy to use, right? Like, I don't have to go to some weird web portal and click around and do all this crap. I just write this really easy software. There's these super easy function calls. And you can actually spin up VLLM servers on Modal. And one of the nice things about using VLLM is you can actually hijack OpenAI's structured generation endpoint, this client.beta.completions.parse thing, send it a pydantic response format, and it will give you the output that you ask for. So you can just use VLLM, you get structured output. You can use anything other than OpenAI if you use your own VLLM. You don't have to send OpenAI money if you don't want to. Okay. And so we're going to do some neural magic stuff. I wish I'd actually seen that talk before I did mine. And so I have this really tiny text. I tried to make it bigger, but I'm using Reveal.js, and I gave up on CSS. But we're using this, the integer quantized weights and not the activations, which I should have done. So you should have sent me more information so I didn't look stupid and have this tiny wrong model.
I had the same picture as Charles.
Okay, well, you guys both should have I'm the only one out of the loop here. So they're good models, but they're all good models, Brett. So neo4j here, I'm using their Aura, which is their cloud managed service, because I was just I don't really want to deal with all this Docker crap, because every time Docker stuff comes up, I freak out, go into sweats. And so I just went on the portal and signed up. And I didn't actually know this, but it does semantic search. I kind of was looking around. I was how do I do RAG stuff? And it turns out that it's really easy to do semantic search. It was a stretch goal. It took me 20 extra minutes. So I built it in as well. So by their powers combined, drum roll please. Thank you. The self-expanding knowledge graph. It's cool, I promise. So what's a knowledge graph? I'll give you the dumb example. We saw a few examples from this. But it's a web, in my definition, it is a web of connected facts and concepts as applied particularly to this example. And so here's how you build a knowledge graph that builds itself. So I'm going to give you a structure because I'm going to define a structure to this graph ahead of time. So I'm going to have a few different node types. I'm going to have the core. The core is the core directive. This is the thing that the model is going to start from. It's what it will always return to. It's the focus. We have a question. This is a thing that the system is trying to understand. What is this core? What kind of questions does this comes out of this core idea? You have concepts, which is like just kind of a vague sense. What is this related to? Think of like hashtags of the mind. And then we have answers. What does the system think it knows, right? It's trying to answer some question that has been asked. And the way we're going to specify this inside of our program is just Pydantic, right? This is just standard ass Python. No, like, I have no nonsense, no crazy imports. I'm just doing like regular code. You're not going to see any complicated agent framework in here, just like really dumb code. So you'll notice I have a question. The node type has to be question. Literal there means like the language model will write question when you generate this. And it has some text there. And the text is whatever the model wants to be, but we'll get JSON that has the fields, type, and text. You do the same thing for concepts. Concepts are also nodes. And you'll note this part here, right here, that has equals field pattern. That's a regular expression. And what this means is I'm requiring that the text of a concept be lowercase with spaces. And so you can actually enforce regular expressions. So for example, if you know that you need to have a phone number inside of there, you can specify the regular expression for a phone number. And so you can extract, if you're doing data annotation, you can extract phone numbers, you can reformat date times, you can do all this stuff. And then I have this type that actually inherits from concept. So it has all the same fields, but it has a relationship type. So the model gets to pick how concepts are related to the thing. So is, affects, or connects to, gets to pick. Then we have answers. They're kind of dumb. It's just type text, same thing. Then we have a bunch of edges here. I'm not going to spend too much time on them, but core, concept, answers raise questions, right? There's additional things that you may want to know about. We have answers. Answers answer questions. At least you hope so. And then there's like different types of relationships between concepts and things like that. Okay. So this is how the knowledge graph works. This is how the self-expanding knowledge graph works. Start at a node. And in this case, we're going to initialize at the core directive, right? This is the central node. Then we're going to perform what's called an expansion. In the expansion, if you're at a question, you can generate only answers. If you're at a concept, you can generate new questions or new concepts. Same thing if you're at an answer. If you're at an answer, there might be more questions and there might be more concepts. So you generate those things, you're sticking them into the knowledge graph, you link it up to wherever you are. Then you go to step 3. You're going to do a traversal. You're going to ask the language model to go to a new node that is related to where you currently are. So the model is going to look around in its neighborhood and say like, I want to go there. Do an expansion there again. Okay? And then you're just going to do that forever until the heat death of the universe. And then you have some kind of weird super intelligent AI that, I don't know. I have one running that, I'm currently running one that says, become a dog. So we'll see. We'll see. Actually, here, you can, nope. Service unable to retrieve routing information. This may be a problem. Uh-oh. Oh, there we go. There's a few in there. What are some toys and chews that are gentle on dog's teeth? Concepts are dog toy. There's some answers. A variety of toys and chews. Keep the dog entertained and stimulated, blah, blah, blah. So anyway, we'll show that in a second. But valid nodes depend on your state, right? If you're at a question, you can only generate answers. And so the thing that I asked the model to generate is actually these things here. From question, from concept, from answer. And so you'll note that from question, you can only generate a list of answers. If you're at from concept, you can generate concepts and questions. And so the thing that's happening is when I give this to the model, when I give the prompt to the model, I will get a from question object back, a from concept object back, a from answer object back. Yep. So here's an example. I'm just going to give you the graph. So I'll show you this prompt. You're super intelligent AI trying to understand question. and that's programmable. So you're going to begin with some core directive. And in this case, it's understand humans. And we want to expand from this core directive. Okay? So one of the first times I ran this, actually, it gave me these two concepts here. It gave me intelligence explains understand humans. Empathy explains understands humans. It raised this question, what is the purpose of understanding humans? And then it also said, can humans be psychologically manipulated? That was the first thing that it generated. So I said, nope, and I shut it down, wiped the graph, and did something else. But that actually happens a lot. It starts bumbling into stuff, partly because I told it it was a super intelligent AI, and that kind of colors things a little bit. And so this is actually the thing that you get from the model, right? Every time I hit the model, I get one of these. Right, so I get a from core, list of questions. That's just a Python list. You can just iterate through that, right? For question and questions, blah, blah, blah. Super easy. And then we stick that in the graph. This is super simple. Pfiffer. If you've never worked with Pfiffer, Pfiffer is perfect for my brain. I agree, actually, that SQL is nonsense and I hate schemas. I don't think ahead and I can't and you won't make me. That's why I use graph databases, so that I can do stuff and then figure out whether it was a good idea later. And if you don't know this, a Pfiffer variant to GQL was actually standardized by the ISO in April, I believe, past April. So it is now it's the most recent query language since like 1970 to be standard by the ISO. So
it was also added to SQL, so SQL now has graph queries
Oh.
in the same standardization. So
Is it really?
Yeah.
Oh, I didn't know
SQL's
this.
got graphs.
I actually had to buy I bought the ISO PDF from some Russian guy in China for $15 because it's like $600 and I wasn't going to pay for that. But I have the ISO standardization textbook if anybody wants it. I can hook you up with my Russian guy. There was a real shady transaction, but now I get a list of every ISO publication every month. Anyway, we're going to transverse to a new node. Probably shouldn't have said that, but. This is the understand humans is going to say, what is the purpose of understanding humans? And then it's going to do the same thing from there. Okay. So behind the scenes, I'm actually constructing this little thing. I'm just kind of like looking at the graph. I'm preparing a text representation. So I get direct connections, and I give it an ID. This is a made-up ID. I have UUIDs underneath the hood, but I use a natural language ID, so it's easier for the model to pick. And you can always force it to pick the correct ID, but when the model, especially for like cheaper models, if it sees a bunch of like UUID stuff, it just starts spitting out numbers and hyphens and stuff. So I gave it like natural language stuff. So then this is the relationship. So node AO explains the concept human social structure. So understand the core explains concept human social structure. Okay, so I'm going to pass that into the prompt. I'm going to put that in here. So I'm going to show you that little box. And I say, hey, please pick a node to traverse to. Give me the node ID. You can also pick core or random. If you pick core, you go back to the core. If you pick random, you go anywhere in the graph. And then the way you do this in outlines is you just say outlines.generate.choice. That's it. You give it your language model. You get a valid node ID, right? So this, valid node IDs. This is the list of node AA, node AB, et cetera. So the model, this traversal generator gives you a function. When you give it any piece of text, it will pick any of the valid node IDs. And the model will like look at the text and be like, oh, okay, I think I want to go over there and pick understand humans. And then you just write code, right? This is the part, choice equals. That's the part where you actually call the code, call the language model. You get a choice. If the choice is core, go to the core. If the choice is random, pick a random one. Otherwise, go to where that picked, right? Super simple. Language model part here, real boring. So in this case, it picked what motivates humans. And then you can see the actual UUID that it picked over here, right? I mapped node AD to this. And then it goes there. Okay, and because we have neo4j supports this stuff, you can actually do semantic traversal. So you embed everything. I just embedded everything. I spun up another modal endpoint here to handle embeddings. And this is actually super, super easy to do. If you've never used Modal, this is the entirety of my embedding function. I have this really, really simple Modal script. I just call this function is modal.function.lookup my embeddings embed f.remote content. That's it. And then I have my embedding. I can move on, inject that into the graph. You can do vector search here with neo4j, right? So this is that call db index query vector.query nodes stuff. And then I'll get the node ID and the score. And then you can traverse by related stuff, right? So you just have this graph that just keeps growing and growing and growing. All right. And then I just add this to the prompt. Semantically related. Here's some other stuff. Here's the similarity, the cosine similarity. And you just do that forever. So I want to, people shout out a core directive. I want to see if we can get it to run live here.
Build a self-expanding knowledge graph.
Build a self-expanding knowledge graph. Ooh, manipulate humans. That one's too meta. Enslave humans? Yeah, let's do that. OK. So I actually have this. Before I wipe the database here, I'm actually.
You already did this one?
No. I did, and you guys are not going to be excited about what happens next. Here's the one for be a dog, just so you can see kind of what it looks like before we go back to scratch. It's just got a bunch of answers and questions and stuff. You can click on any of these, and it's just like there's this big like answer block here. I don't know if I can click on one of these. Yeah, here. This one is like, how is the process of dog domestication influence modern dog behavior, right? So that's just like crap that happens. So I'm actually going to spin this up here, and this here is enslave humanity. Okay, and then let's go ahead and run this. So it'll take a second to spin up, but we can actually watch the model think here. Current node, core, enslave humanity. This is the stuff that we're feeding in. I give it its traversal history so I can see where it is. And it'll say, OK, so this is the prompt that's going to go into it. And it's added subservience and control as concepts to the core. Okay? And then it starts adding things like enslave humanity as the core. It moved to the concept of control. It added brainwashing, programming, mind control. Then it starts asking questions like, how does brainwashing affect the human brain? What are the effects of long-term brainwashing? Can brainwashing be used to enslave humans? You can see the stuff that's being added here is all like semantically related stuff. It went back to the core enslave humanity as it should. Now it's going into concepts of like indoctrination. It really likes focusing on enslaved humanity, which I love. We asked it for this. So
Return to core.
return to core. Always return to core. So now it's actually running for a long time. So I imagine it's spitting out quite a lot of text. But I'll show you kind of what this looks like inside of the graph, because I actually really enjoy this. So you can see enslave humanity there. You can see it's added brainwashing here. The concepts will actually start becoming more interconnected because I match by text. So it'll find something with a matching concept text and just start linking them together. So everything that's a question and an answer and stuff, they spin out from concepts, but concepts get densely connected. And so you can always traverse through concepts to get to something else.
It's thinking about starting a cult.
It's thinking about starting a cult. Let's see here. So now it's like, oh, there we go. Cult.
Yes.
What are the long-term effects of brainwashing? Long-term effects of brainwashing can be severe. Brainwashing, blah, blah, blah. So mind control we're using for therapeutic uses. It's going to be OK, everybody. Curing your depression.
And this is only an AP model.
Yeah.
Yes, there's actually some debate about whether or not structured generation can be used to jailbreak, because you can force something to start in a particular way.
Yeah.
And you can add all these things to your field. So I would love to see people actually experiment with that. But I'll leave it there for now. If you like this, please go look at Outlines. That is an open source package. It's fun to play with. I really, really like it. Go find us online. We've got Twitter. We have our website. There's the GitHub. You can find me on Twitter and Blue Sky, and LinkedIn if you want, but I won't say much. That's where I put on my fancy hat, and I'm like, come see me today, and blah, 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 blah. But Twitter's fun, and Blue Sky. I actually prefer Blue Sky. I'm doing more dirtbag stuff there. So anyway, I'm Cameron Pfiffer, work at dottxt. Please come get a sticker. I've got tiny small ones that were an accident, and then I've got big ones that are real, but I prefer the tiny accident ones. So thank you very much.
Time for a few questions. Unless people kick us out, we're gonna stay as long as we can. Questions?
Is this repo public?
Is this repo public? Yes, this repo is public, I believe. Let's see if I put it up here. Yes, it's under, oh my God, I can't type. It's under C. Pfiffer self-expansion on GitHub. Wow, that, you know it's on GitHub. So it's in here, you can go run this. You have to spin up the Modal servers. I don't have anything in the README because I'm a really bad engineer, but I probably should. But you have to spin up these the two inference servers for the embeddings and for the BLLM inference. And then you just call Python expand.py and write the core directive in there, so you can experiment with it. Let's see what it's doing now. Wow, it's really working on it. Oh, what population groups, military personnel, cult members, and children are targeted. So you can really play with this. I took this and really hammered on it on a personal project. You can go nuts. I mean, this is crazy. And so I think the takeaway I want you to have from this is like, you can build crazy things. I mean, really crazy things. And I don't mean like crazy in the sense that like, we're watching this thing try and determine how to enslave humanity. But I mean that like, this is really simple. This is just like standard language model stuff. I wrote really simple code. I don't ever worry about the language model doing stupid stuff. And it is a really creative, beautiful endeavor. I found this is like one of my favorite projects. I got to sit down and it made me really happy. Yeah, any other questions?
Mike will bring you a mic.
No, he's got it.
So seeing how we're talking about sort of visual systems for representing ideas, can we just talk about how this is useful for, like we talked about, humans understanding computers and making it more human understandable, demonstrably showing what resources don't have a lot of graph connections for a business or for a project team, and using this to show off where you're starving some ideas or portions of it. Is that a good use case for this, or is that possible?
Yeah, I mean, honestly, like, you know, I think, did Jason mention this? Kind of earlier on about kind of like good techniques for doing graph rag where you kind of like inject, you know, questions and stuff. In principle, if you have business logic in here, you could write something on top of this that just combs through whatever you have and says like, should we be doing that? Or something like this, right? And you could sit this thing on top of your underlying data structure and allow it to understand something. And you could give it your own like custom core directive and be like, how are our sales doing? Or whatever, right? So that's one application.
What was here? Oh, Mike will, yeah, we'll need to get you. Is that question, Mike?
Oh, sorry. Okay.
So I'm not like AI native, but I'm trying to learn more about the space, and like agents have been popping up a lot. So could you do like agent orchestration swarms with this so that they can like interface with each other as well? Or, like,
You could. There's a lot of discussion about what agent means, and what the thing that people have come to coalesce around is that an agent is a very complicated technical framework on top of what is ostensibly a very simple program. So in this case, actually having them talk to each other, I don't even know what that means. All I have is like, they're just putting text in the graph. So any of them can go pick this up. All I do is I write standard control flow. They just go pick up whatever text is in there. I don't have to use any like, you could like, agent orchestration in this sense, it's saying like, is just adding Python multiprocessing to several of these worker agents, essentially. And that's not, that's not like some kind of true blank chain, whatever thing.
When I think of agent orchestration, I usually just think of chain prompts at this point, but like.
Yeah, and
It's kind of strange, I guess.
yeah, I mean, I think this is like, I think the agent framework is actually kind of reductive. I think it pigeonholes you into thinking about agents as flows of prompts rather than building these systems into a comprehensive compound AI system that is built like a standard program, like software. And inside of the control flow, yeah, there's chain prompts, but I think it's I do think it's kind of a reductive description. So, but yeah, this is technically an agent. This is by modern definitions of that term.
Yeah, I just wonder, like,
Just speak up.
okay, can you hear?
It's for the recording.
Oh, right, sorry. So, I just wonder, like, if it's like more like scientific data that's like limited. Can your system go back to or to comment on like the agent? I think this is like much better than using like
I agree.
from engineering like to the best. But yeah, I just wonder, like, for example, like, can human live forever based on like Brian Johnson's kind of like invention? But it's like kind of like limited right now.
Based on the information that it has handy.
Yeah.
Yeah, of course. I mean, this is a toy example, but for example, you could start adding groundedness, right? So you could start adding fact nodes. These are things that are added by humans, right? These are things that we know to be true.
Yeah. So
And then you could add
how
fact
can you
checkers
do
and things
that?
like that.
Can you put like the knowledge also like self-expanding, or I mean like the data self-expanding as well, or just?
Yeah, I don't see why not. It's a more complicated system, but absolutely you could do that.
Okay.
Yeah, yeah. Cool. Oh, you got one back there.
Let's do one more question and then
Yeah.
if we have time left, we can.
And you can also come chat with me after too.
Hey, I'm actually neo4j over here. So I'm wondering, is there any reasoning logic that you're using when deciding jumping between the core node versus just a random node?
That's up to the model.
Interesting.
Yeah, so the model gets to pick where it goes. And in principle, actually, one of the things that you can do, I'll give you like a super quick example of this. One of the things that we tend to do when we work with stuff like this is you can actually have structured reasoning fields. So for example, I can do like this. How do you spell reasoning? You can actually add a reasoning string like this. And so the model will be forced to output reasoning before it outputs the other stuff. And in principle, in the traversal section, you could add a reasoning, and instead of doing the regular expression completion, you could have it complete one of these objects, add a reasoning, then choose a node to go to, and then it would have to explain why it's going to a node. And that would actually be very cool. So you can do all kinds of stuff like that, but the model gets to pick. Yeah, of course, good question.
All right, thank you, Cameron.